This is a photograph from the early 1980s showing the release of the first commercial compact disc. A CD holds massive digital data, but without the highly engineered optical laser and audio outputs of the player, that disc is useless. Today's large language models face the exact same limitation. You can think of a bare, raw AI model as a high-performance V8 engine, running at full throttle. Without a chassis, a transmission, or a steering wheel, it isn't driving anywhere. It's just violently shaking itself apart. This chart shows the performance curves of major AI models like ChatGPT, Claude, and Gemini over recent release cycles. Look closely at the top right. These supposedly distinct models rapidly flatline and converge into a single baseline of capability. Access to a highly capable language model is no longer a unique advantage. It is universally available. Trying to build a business strategy entirely around accessing an AI model is identical to trying to compete on access to basic electricity. Nobody competes on electricity. The value comes entirely from the proprietary appliance you build to plug into the wall. In the world of enterprise AI, that appliance is called a harness. A harness is the structural scaffolding built around the model. It handles the memory, dictates the logic integrations, and intercepts unpredictable text generations before they can corrupt a business process. If a competitor uses the exact same language model you do, but they possess superior context management and error handling, they win the market. The raw AI model offers zero competitive advantage. The proprietary harness engineered around it is the only defendable business moat. To understand how to build that moat, we have to look at what actually goes into a functional harness. The starting state is always a raw, isolated AI model, completely disconnected from your enterprise data and daily actions. The first component we add is the prompt layer. Raw user instructions and contextual data are structurally assembled here before they ever reach the model, guaranteeing the AI receives instructions in a precise, standardized format. Next, we add tool connections. An isolated model can't access live information, so we wire it to safely query external databases, search the web, and communicate with specialized API hubs. Step 3 is memory and context management. Models lack internal object permanence regarding what happened 3 minutes ago. This loop constantly feeds previous outputs back into the intake to maintain the exact history of a task. Step 4 is output handling. Language models naturally generate raw, unpredictable text strings. This component parses that chaos, extracting only the specific data fields needed to route a clean signal to downstream software. Finally, we surround the assembly with guardrails and evaluation. Because the system relies on probability, it will occasionally make mistakes. This shield actively intercepts hallucinations and out-of-bounds requests, neutralizing them before they trigger an action. Without these 5 interconnected structural components, a business does not possess a functional AI system. They simply have an unpredictable liability masquerading as a solution. To actually construct this scaffolding, engineers generally choose between 2 primary toolsets. The most accessible route utilizes low-code orchestration platforms like N8N or Make, which offer pre-built visual blocks to wire AI directly into daily workflows. The alternative route involves programmatic frameworks, such as LangChain. These demand deep coding expertise and significant developer hours, but they grant engineers absolute architectural control over every single variable inside the harness. Notice what is conspicuously absent from both of those construction methods: AI research. The scientists adjusting neural network weights in a lab are solving a completely different mathematical problem than a business trying to execute reliable daily operations. Because large language models operate by predicting the next most likely word, their baseline outputs are inherently probabilistic. For a business workflow to survive contact with reality, that unpredictability has to be locked down by rigorous, deterministic software engineering. This creates a massive advantage for traditional IT professionals and managed service providers. Their entire historical core competency relies on mapping strict business logic, mitigating operational risk, and guaranteeing system uptime. When those professionals begin building, they operate under a strict initial constraint. They never deploy a fully autonomous, agentic system right out of the gate. The smartest engineering mandates that internal workflows act as the testing ground. Human-in-the-loop validation, where a staff member reviews and approves the AI's output, is the absolute prerequisite to building trust in the harness. Transitioning from theory to deployment requires a highly actionable blueprint. The most effective strategy is to target a specific, highly bounded internal bottleneck, something repetitive and isolated, like IT ticket triage. Step 1 is defining the exact data contexts. You must explicitly determine what documentation, client history, and internal rules the model needs to read in order to accurately classify an incoming ticket. Step 2 requires selecting your bounded internal integrations. Decide precisely which databases the model is permitted to query, locking its access down to just the ticketing platform or a specific knowledge base. Step 3 maps the exact workflow logic. You are laying down the strict, step-by-step sequence of operations that the model is forced to follow to complete its evaluation. Steps 4 and 5 combine error handling with active monitoring. You architect specific checkpoints where a human reviews the AI's categorization to evaluate if the task genuinely succeeded, trapping any failures long before they reach a client. It comes down to a clear division of labor. Humans steer while agents execute. The ultimate quality and safety of an AI deployment rely entirely on strict, auditable human validation hooks. The entities that dominate the next decade of technology will not be the organizations that possess the deepest understanding of neural networks. They will be the master engineers who build the tightest workflows around them.